the focal length of any of these spherical mirrors is equal to half of the radius of curvature. That is the first expression. Second is the mirror formula, right? Mirror formula is what? It says 1 by u plus 1 by
1
v
by V is equal to 1 by F.
1 by f, which is nothing but 2 by r,
Yeah.
right? Because f is r by 2.
R2.
This is the mirror formula, and it is similar to lens formula. There is a slight difference between this and the lens formula. That is 1 by v minus 1 by u. That is the only difference. Okay, so this is your mirror formula. And when it comes to magnification, magnification is h2 by h1, where h2 is height of image, h1 is height of object. So
Object minus V by U.
yes, so that is also, yeah, that is equals to minus v by u, and it is also equal to f divided by same. If you apply yesterday or in the last class, we have seen this derivation as well, right? So it will be equals to f divided by f minus u, or f minus v divided by f,
V.
right?
Yeah.
These are the formulas for magnification. Magnification is negative. I mean, if it is a real image, in a real image, the magnification is going to be negative, because the real images are always inverted. So because real images are inverted, so the H2 will always be negative, right? Because H2 will be like, this is H2 and
Yeah.
this is H1. So H1 is going, I mean, you can see the direction is two different directions. So one will be negative and other will be positive. Basically H2 will be negative and H1 will be positive, and that's why it will be always negative for real image. So magnification is negative for real image, and obviously it will be positive for virtual
Yeah.
image. And we're going to
Virtual
discuss.
image.
So this is about the magnification. If it is a
Yeah.
concave mirror, right? In case of concave mirror,
This real image.
concave mirror is like this,
Yeah.
right? So in, no, you will get even virtual image in this
Last
case.
situation is virtual.
Yes.
Yeah.
So in case of concave mirror, we are talking about focus and R. So F and R both will be negative. We will take it as negative. As per our sign convention, anything which is in the opposite direction of the incident ray, that is negative. So in case of this, right, you can see incident ray will be in this direction, and your radius of curvature, because everything has to be measured from pole. So you can see the radius of curvature will be what? Say for example, this is P, this is C, radius of curvature is CP. So CP, this means from, sorry, from pole to C. So that is against the direction of incident ray, and that's why R will be negative and even F will be negative in case of concave mirror. So now I'm not going to write for convex mirror. You know what will happen for convex mirror. Both will be positive, right? For a
Yeah.
real object, U is negative, V is negative for real image, and positive for virtual image. We have already seen that. That's all. So these are the sign conventions which you have to use, and these three are the formulas which you have to use. Now, based on this, we have to solve this above question. So let me now copy these question once again. So these are the formulas. I think F equals to R by 2. You are already aware of this. I'll remove that. This from here. Now try to solve this question.
Yeah. Plus 10 itself.
U as minus 10 or 10. That is what your question is. So see, it is concave mirror,
Yeah.
right? In
Yeah.
concave, U will be what? U will be, you can see object will
Negative.
be kept here. Yes, so
Yeah.
object is kept here. So U is this distance. So if U is this distance, it is again you have to measure from the pole. You are going against the incident ray. So U will be taken as negative. So if it is 10, it will be taken as -10.
Yeah. Um, 15. In the formula also, when you're doing f by f minus u, do we take like both f and u as negative, or do we keep it the same?
Negative.
Both are negative, right?
Yes.
Okay. Yeah, sir. For the first thing, 10 centimeter, the object is between f and 2f. Image is beyond 2f, and magnification is 3.
Okay, what is the exact position of V?
Okay, one second. Let me do.
Oh, and even before that, what is the focal length in this case? F
7.5
-7.5.
minus 8. Sorry, minus
Oh,
7.
good. Yes, and in the first case, U is 10 centimeter. That means actually we have to put -10 centimeter because it is concave mirror. Okay.
Uh, so I got V as minus 15.
-15.
It's wrong. It's wrong.
Let us see. This is the formula you will be using, right? 1 by E is equals to 1 by F minus 1 by U. Right?
Yeah, so no, what I did was I found magnification and I use f minus v by f.
Okay, even in that case, you will get the same thing. So maybe the
Yeah,
magnification. What is the magnification you got?
3.
Okay, magnification is -3. It is real image.
Oh, that's why. Okay, okay, that's why.
Yeah.
That's
So
why I got it.
here in this case, obviously, you should actually start ideally from this equation, right? The mirror formula: 1/u plus 1/v is equals to 1/f. So we have to find v. So I have rewritten this the formula as this. So now from here you can see 1/v will be equal to 1/f. 1/f is -7.5, or it was 15/2. So let's write 7.15/2, right? So this is -2/15. So that is minus
Yeah.
1/7. So okay, and then -1/u. U is -10. So this is 1/10 minus 2/15. LCM is 30, and it will have 3 minus 4, that is equals to -1/30. That means V is equals to -30. -30 means it will be formed on the same side where the object is, which is the most, generally these are the cases in the concave mirror, right? The image will be formed on the same side in which, or on which, the object is lying. So that is V. So V is negative. That means it's a, now coming to the nature, it is real image, it is virtual image. So it is real, it is virtual, and it is formed at 30 centimeter from the mirror on the same side as the object. That is the first part. That is one of the parts, two parts of the first question. Now the magnification. Magnification is what? Magnification is
-3
minus V divided by U.
by u.
So minus V means plus 30 divided by
Yeah,
U means
by
minus 10.
-10.
So that is equals to -3. So this
3.
is magnification. So from this also you can say that it is a real image. But now from this also you will get, I mean,
I
first you
got
get
it. Yeah.
magnification, and then also you can find V. But yes,
Yeah.
obviously, you had +3. Your answer was +3. So that was the reason. How did you get magnification without V? Which formula you have used?
That's what f by f minus u.
Hmm. Okay, so from there also you can see f minus V divided by f will be equal to -3. You will get the same value of V.
Yeah, yeah.
F minus V is equals to -3 into f. F is -15/2. So -15/2 minus V is equals to 45 divided by 2. So V is equals to -60 divided by 2, which is -30. Okay, similarly, you can solve the second one. Try solve the second one and see if there is any difference in the nature of
Yeah.
image.
It should be virtual.
Because it is between focus.
Between pole and focus.
Yes, exactly.
Magnification is +3.
So again, you found magnification first.
Yeah.
No problem.
plus no. Yeah. V is plus 15.
V is plus 15, correct. Okay, so that means what? It is on the other side of mirror,
The mirror. Yeah.
right? So it is on the other side of mirror at distance 15 from the pole. So this is where image is formed. And obviously, if object is here and its image is formed on the other side, this simply means that it is a virtual and erect image, right? So this is virtual, erect, and uh, located on the other side of mirror, right? And magnification is plus 3. That means it is 3 times more or 3 times longer than the original or the object.
Okay.
Okay. Now, next question is again question from NCRT. And these NCRT problems, right? I'll ask you to solve all the problems of NCRT,
Okay.
right? All the problems of NCRT, you must have already solved, or you still,
Yeah.
uh,
Yeah.
okay. So these questions are very important questions, even from the exam point of view. This time we are
Yeah.
expecting questions to be from the NCRT itself. You should solve other
So
problems as
do
well.
we have to solve the additional exercise also
Yes,
for
it is
boards also,
necessary
right?
because now you have more time. So just utilize
Yeah.
that
Yeah.
time in solving more problems. Okay. Now this problem is again a very important problem. Here it is about moving object or moving mirror. So it says if you sit in a parked car, you glance in the rear view mirror whose R is equals to 2. So this is the rear view mirror's radius of curvature, which is 2 meters. And notice a jogger approaching, right? So mirror is fixed. The object, which is jogger, that is actually approaching that mirror. So suppose this is the mirror is being approached by this person. Jogger is running at a speed of 5 meter per second. So that is the speed of jogger. He is running at 5 meter per second, obviously towards the mirror. How fast is the image of the jogger moving? So next
Wait.
what will happen? You will see the image of the jogger, right? And do you see inverted image, or in the rear view glasses you see the erect image?
Direct image.
Okay, so that means those images are virtual and erect image, right? And even
Yeah.
this mirror is not concave mirror. This mirror is actually
Convex.
not convex mirror. So rear view mirrors are always convex mirror. If there is or any confusion, just think about that. However close, however far is the object in the rear view glasses, they never appear to be inverted. They are always, so if it is erect, that means it is always virtual.
Yeah.
If it is always virtual, that means the convex mirror, the mirrors in the rear view mirror are actually convex mirrors. So this is the situation. The radius of curvature is given, is 2 meters. The speed of the jogger is given, that is 5 meter per second. And you have to find the speed at which the image will move. But the speed at which the image will move will also differ in different situations. So when the jogger is, so there are three different situations for jogger given, or three different positions for jogger given. That is 39 meters if the jogger is at 39 meters. If the jogger comes at 29 meters, and then if he is at third position, that is 19 meters, and fourth if he is just 9 meters away. So in all the cases he is actually beyond radius of curvature, because radius of
Yeah.
curvature is only 2 meters. So the minimum distance from the mirror is given 9 meters. So 9, 19, 29, and 39. So in all these cases, he is actually away or beyond the radius of curvature, beyond center of curvature actually. Okay, so now can you tell me what will be the speed? In all these cases, you have to find speed of image. Obviously, because object is moving, so the image will also be
Hmm.
moving. So what will be the speed of image in all these four cases? That is what you have to find.
So at 39 meter, he is 5 centimeter per second, right? 5 meter per second.
That is the speed of jogger, that is constant. So at 39, at 29, at 19, at 9, the speed of jogger is not changing. That is all, that is fixed to 5 meter per second.
Okay, okay. This is the rate of image formed. That's what you have to find, right?
Yes, speed
The
of
speed
image.
of image.
The object is moving in the mirror, even image will be moving. So if object is moving at a particular speed,
Yeah.
object speed is always 5
Image
meters.
will be also same.
What will be the speed of image? That is what you have to find. Will it be same? Yes. The first question obviously should come
Yes.
into our mind is that it is reflecting the
Yeah, yeah. The
object
distance from the object to
5
mirror
meters.
is same as from image to mirror. So it is same.
Okay, so that is our uh, guess, right? So we'll try to solve this question. This question is very important. So as the rear view mirror is convex, we have to write here that r is equals to plus 2 meters. Then we have focal length. Focal length will be equals to plus 1 meter, which is half of radius of curvature. Now
Yeah.
the image position we will try to find out. So in order to do that, we'll have to use this formula. 1 by v is equals to 1 by f minus 1 by u. So from this,
Yeah.
you can say what will be v. This means 1 by v is equals to u minus f divided by uf, or
Yeah.
simply v will be equal to, we are just finding a final expression for v so that we can directly substitute values in this. So v will be equals to uf divided by u minus f. Any doubt?
Yeah. No, no.
So now three different cases. First case, when the
At 39.
u is 39 meter, obviously it will be minus 39 meters because the object is on the left hand side. We have kept it on the left hand side. So this is minus 39. So what will be v here? Substitute the values. Minus 39 into focus, which is 2. Sorry, focus is 1. I mean the focal
1
length
point something.
1 divided by u minus f. That is minus 39 minus 1.
Yeah.
So that is minus 40. So this is minus 39 divided by minus 40, which is simply equals to 39 divided by 40 meters. So this is
Point.
the first case. Second case, u is equals to 29. Okay, before going to that, so this is about, let's be here itself. Okay, now we have to find at this point what will be its velocity. This is only the position of the image. So
Yeah, yeah.
image will be at 39 divided by 40 meters. Okay, so as the jogger moves at a constant speed of 5 meter per second, that means after 1 second,
He moves
after
5 meter.
he moves 5 meter, that means what will be u? Will it be minus 30?
39 by 40 by 5.
This is
Yeah.
after 10, sorry, after 1 second, it will be minus 34 meters. It will move by 5
Yeah.
meters. Okay. Now at this position, if I have to find the position of image, I'll just use this formula u, that is minus 34 into 1 divided by minus 34 minus 1, that is nothing but minus 34 divided by minus 35, which is 34 divided by 35 meters,
Okay.
right? So in 1 second, this is the distance it has traveled from here to here,
Yeah. So that's a
39
speed.
40 to 34 by
Subtract it and
35.
that's
So
a
that
speed.
means what is the velocity? So velocity is
5
nothing
meters
but
per second.
so final position minus initial position, that is,
Yeah.
or
34 minus
39 by 40,
39.
yeah, minus 34 divided by 35, or opposite of this. Okay, if we are finding this 39 by 40 minus 34 by 50, you will get how much? 35 into 2, 70 into 2, or simply multiply 1400.
39 to
Okay,
35.
yeah, 39 into 35. Let me see the
Wait,
question itself. 1360. So that is 5 divided by 1400, which is 1 by 280 meters. So this 1 by 280 meters, it has traveled in 1 second. So what is its velocity? It is 1 by 280 meter per
Yeah.
second. So the velocity is 1 by 280 meter per second. And what is the velocity of the object? You can
5
see
meters
here,
per second.
it has moved by 5 meters in 1 second, but here it is not even 5. It is 1 by almost 300th of 1 meter. It is
Yeah.
1 meter. So that means image is moving very slow as compared to object,
Okay. Okay.
right? So this is how numerically you can prove it. You understood? Numerically you can prove it. And even without finding these numbers, you can actually conclude this without finding these numbers. How to do that? Just by logic. This is the convex mirror, and we know that, suppose the object is at some point over here, which is beyond focus. If object moves from, say, beyond focus to this point where there is focus, actually this is convex mirror, you know that in all the cases you will get a erect image on this side, right? So in this case, when the object is at, in case of convex mirror, when the object is uh, at any point behind the mirror, right? I mean, as you can see in this case, it is in front of the mirror. At any point you will always get a diminished image, right? For
Yeah.
any position of the object between infinity to pole,
Yeah.
that is from infinity to pole, wherever is this object, right? The image is behind the mirror, it is erect, it is virtual, and it is smaller than
Undiminished.
the object. So after striking this, it will go through the focus. It will appear to go through the focus. It cannot go through the focus, right? So this will actually reflect in this direction, right? And if it goes through the center of curvature, it will go like this. So it will intersect somewhere over here. So this will be always smaller than the object. That's what you see in rear view mirror. For example, even if
Yeah.
the truck behind you, in the rear view mirror, you will always see
Appears small.
smaller image of truck. So whatever
Yeah,
be the
correct.
size of truck, if it is behind you in the rear view mirror, it will appear always smaller. So the image will be always smaller. Image will be always erect. That's what you see in your rear view mirror. It is always erect and
Yeah.
always smaller,
Hmm.
right? Now, maximum where it can go, maximum where it, right now the image is here. If it is here, if the object is here, let's say this is the position of the object, then in this case, what will happen? If it comes very close to you, then what will happen? it will be the same situation. Actually, you will see that in this situation, it will again pass through focus, and then this will pass through the center of curvature. So that will go through the center of curvature. Now the image will be little bigger than the previous. So now even this is a practical scenario in your rear view glasses. When the vehicle comes closer to the mirror, when the vehicle approaches you, so as the distance between the vehicle and your rear view mirror, the vehicle which is behind you and the rear view mirror, if it decreases, the size of the image increases. You observe that, right? And what you are seeing here is this image is actually moving in this direction. Yes or no? Image was here, now image is here. So image is moving in this direction. Maximum it will move from this center of curvature to the pole. So maximum distance it will cover is this center of curvature to pole, which is equals to r. It
Yeah.
cannot cover distance more than this. And in the same time, you can see when it will be formed, no, not even radius of curvature, it will be at focus. When it will be at focus, when the object is at infinity. So when the object is at infinity, your image will be formed at, so when the object is at infinity, image will be formed at focus, and that will be a point object, point image, right? And as the object approaches mirror, you see that the image will also try to move towards the mirror in the backward direction. So when the object is traveling from infinity to pole, the in the same time, image has traveled from focus to pole. Is it correct?
Yeah.
So in the same time, object versus image. What do you think? Which one has covered more distance in same time? Object or image?
In same time, from object image. Yeah.
Because object is
Object.
traveling from infinity to pole, while
Yeah.
in the same time, image is
Same.
traveling
It's just pole to
focus to.
pole.
So
Focus.
obviously the image is traveling faster. Any doubt in that? So image is all, sorry, not image. The object is always traveling
Object. Yeah.
faster than the image, or the image is always traveling at a speed which is very less as compared to the speed of object. Agree?
Yeah.
So without actually going through the numerical, this is the basic explanation of this, that image is always traveling at a very lower speed as compared to the object, and that's why in your rear view glasses that warning message is always there, that
Yeah.
which you are seeing, the image which you are seeing is
Not the real
not the,
distance
yes,
between the.
yes, the distance between the between the vehicle and I mean between the two vehicles is less as
Yeah.
compared to what it is
What
visible
is game?
mirror, because it is the because of the speed, the time taken by the object to change the position is very less as compared to the time taken by the image to change the position, right? So this is the first part of this question, the numerical. I mean, this is the basic theory part or the explanation part, and here we have even solved the question, the numerical. Similarly, you can solve it for the second part as well. If you want, it will be same thing. It won't be very difficult. Same
Yeah.
thing you
Yeah.
have to do, and you will see that the next. So here, what was the speed we have got? So I leave it to you to solve this. Similarly, you solve it for second situation, third situation, and fourth situation. I'll just give you the answers, and based on that, I'll explain you what is the outcome of this problem. So when u is at minus 29 centimeter, that means little closer to the mirror. In that case, the velocity is 1 by 150 meter per second. Then
It's
if
increasing.
is minus 19, correct? In that case, the velocity is velocity of the image is 1 by 60 meters per second, and when it is minus 9 centimeters, that is just 9, sorry, meters, these all are in meters. So when it is 9 meters, in that case the velocity will be 1 by 10. This should be the answer. You can make a note of this, or this will be in your NCRT itself, so there you can simply verify your answers. Now here what do we see? The velocity of the image is increasing or decreasing?
Increasing.
It is increasing, but still if it is at 9 meters, even at that time, it is 1/10 of the original speed, 1/10 of the speed of the object. So when it 9 meter is a very short distance, right? So
Hmm.
at that time also the speed which you will see will be only 1/10 of the original speed, or 1/10 of the speed of the object. So that's why you have to be very careful about the about the conclusion which you make about the things at your back when you are driving.
Yeah.
So speed becomes very high as the jogger approaches the car. The change in speed, this right, it can be experienced by anybody while traveling in a bus or a car. You can actually experience this, and that's why this is very important. It has a very important practical application. Very important.
Yeah.
Okay, so let's see another question. So there is a square wire. All these questions are from NCRT.
Yeah.
Try to solve all the problems from there. A square wire of side 3 centimeters is placed 25 centimeter away from a concave mirror. So there is a concave mirror whose focal length is equals to 10 centimeter, and the square wire, there is a square wire of side 3 centimeter. It is placed 25 centimeter away from the mirror.
Okay.
Concave mirror of focal length 10. What is the area enclosed by the image? So again, a very interesting question. What is the area enclosed by the image? So you have to understand that it is a concave mirror. So in mirror, if it is not at center of curvature, the there will be a magnification. The image will
Yeah.
be magnified. It will be either diminished or it will be magnified, depending on the position. Only at center of curvature the magnification is 1. That means there is no change in the size. So now because of this,
Beyond 2F. So
yes, so
image
wherever
is diminished.
so wherever it is, there will be change in the, because there are three there. This is square wire, that means of 3 centimeter sides each. So that means this 3 centimeter will not be 3 centimeter in the image, and that's why the sides, each sides of the square wire will also change, and that's why the area of the enclosed image or area in the image will also be different.
So to find for each side as an object, I find, right?
Once whatever one side will experience, whatever will be the magnification in one side will be there in all the sides. No.
Or what if the object is for up and down? Like
See here,
if
if
the
it is
object, like the when you're finding the upper side of the square, that will decrease, right? So will the magnification still be same?
why upper side will, all the sides will have the same. See, this is the square.
Okay.
Do you think there will be different magnification for different sides?
Uh, hmm, it should be same. Yeah. Let me check. 1 by u.
It will be same, right? All the wires
Yeah.
are at same distance, right?
Hmm.
It's not like this. The wire is not kept like this. Wire is
Yeah,
kept
yeah,
like,
got it.
okay. Yeah, go ahead.
I made the wrong. I bit the other side. That's why.
No problem. No problem. Because that will be little difficult for you to do, because every point on the wire will be at different position or different at different distance from the mirror, if we take that scenario.
So V is 7.1 centimeter.
V is 7.1. Let us see. F is -10. U is
Concave.
25. We have to find V. 1 by V will be equal to 1 by F minus 1 by U, which is equals to -1 by 10 plus 1
Minus
by,
1 by. Yeah, plus 1 by 25.
so 25 and 10, 50 will be the LCM, minus 5 plus 2, so that is -3 divided by 50, or V will be equal to -50 divided by 3.
Oh, oh. Sorry.
Okay, and then you will have to find the magnification.
Uh, 1 second. Minus 10 plus 25. Yeah, 250. 15. 15. So V is minus 50 by 3. Yeah. Magnification minus V by U divided 3 by minus 25 minus 2 by 3. Yeah.
Okay, so this is the magnification. You must have got this, that magnification is -2 by 3. What does that mean? See, magnification, we know that magnification is what? It is h2 by h1. That is height of the image divided by height of the object. That means what? That means h2 is equals to m into h1. There is a negative sign, but okay, if you want to include, you can include that negative sign as well. So in that case, what does it mean? It means that h2, which is the height of image, that is equal to -2 by 3, right, to h1. And h1 is what? Original size is 3 centimeter.
3.
So that means it is 2 centimeters. -2,
Yeah.
but okay, because it is an inverted image, so h2 is -2. That means the square which will be formed will be of
We have 2 centimeter.
every side will be
Side is.
reduced to 2. Earlier it was 3. So this is correct. Every side will be reduced, so this image will be
Yeah.
diminished. Its magnification will be uh, less, and that's where, what do you have to find? You have to find the area of the enclosed image.
Area.
Is equals to 4 centimeter.
4 centimeter square.
Okay, so these were few questions from your NCRT book. There are more questions. Try to solve the questions based on this topic and the topics which we have already covered, that is refraction, plane surface, curved surface, lens formula, lens formula. Try to solve questions based on those topics and let me know if you have any doubt. In our next class, we'll try to solve few more questions. Okay, and
Yes,
we'll
sir.
try to cover these topics, I mean numericals based on these topics, and then we'll
Sir,
move
free this
to
weekend?
optical instruments. Yes.